Isaac Newton, one of the most influential scientists in history, made groundbreaking contributions to physics, mathematics, and astronomy. His work laid the foundation for classical mechanics and significantly advanced our understanding of the natural world. 1. Laws of motion. Newton's most famous contribution is his three laws of motion, which describe the relationship between the motion of an object and the forces acting on it. First law, law of inertia: an object at rest stays at rest, and an object in motion stays in motion at a constant velocity unless acted upon by a net external force. This law introduces the concept of inertia, the tendency of objects to resist changes in their state of motion. Second law, F equals ma, the force acting on an object is equal to the mass of the object multiplied by its acceleration. This law quantifies how the velocity of an object changes when it is subjected to an external force. It's often written as F equals math equals ma. Third law, for every action, there is an equal and opposite reaction. This means that forces always occur in pairs. If object A exerts a force on object B exerts an equal but opposite force on object A. 2. Universal gravitation. Newton proposed the law of universal gravitation, which states that every mass in the universe attracts every other mass with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. This idea was revolutionary because it explained why objects fall to Earth and why planets orbit the Sun. The equation is F equals gm1m2 2 F equals gy. 3. Calculus. Newton, independently from Leibniz, developed calculus, a branch of mathematics that deals with continuous change. Calculus is essential for describing motion, growth, and decay, and it underpins much of modern science and engineering. Newton used calculus to solve problems in physics, such as calculating the orbits of planets and predicting the motion of objects under various forces. 4. Optics. Newton made significant contributions to optics, the study of light. He conducted experiments with prisms and demonstrated that white light is composed of a spectrum of colors, which can be separated and recombined. He also developed the first practical reflecting telescope, now known as the Newtonian telescope, which used mirrors instead of lenses to reduce chromatic aberration. 5. Principia. In 1687, Newton published his most famous work, the Philosophiae Naturalis Principia Mathematica, commonly known as the Principia. This book outlined his laws of motion and universal gravitation, providing a comprehensive mathematical framework for understanding the physical world. The Principia is considered one of the greatest scientific works ever written and remains a cornerstone of physics. 6. Impact and legacy. Newton's work revolutionized science, providing the tools and concepts necessary to understand the natural world in a new and precise way. His laws of motion and gravitation dominated scientific thought for centuries until the advent of quantum mechanics and Einstein's theory of relativity, which expanded and refined Newton's ideas. However, Newton's principles are still used today in many fields, from engineering to space exploration. Isaac Newton's contributions are a testament to the power of human reasoning and the quest for knowledge, marking a turning point in the history of science.